In this lesson, we work a little more with these fractions, decimals, and percents. Now, before we get into anything that's new, I want to do a little mini review here, especially with my pen working. There it is. Do a little mini review here. So these questions are like what we saw in the last lesson. So at the runoff election, 180 out of 300 chocolatiers, they voted for truffles. Expressed as a reduced fraction, decimal, and percent. So what they're saying is, hey, just make a fraction, decimal, and percent out of these numbers. Now notice the 180 out of 300 is kind of telling you, well, that's the part and that's the whole. We took 180 out of 300 and they said they voted for truffles, right? So when you have if you want a fraction is part over whole. Always, always, always. And so you put the 180 on the top, you put the 300 on the bottom. Remember all this stuff, and the important thing is to reduce. Well, I can cancel the 10s, top and bottom, 18 over 30. And now I can cancel, you can go for 2s if nothing else. If you don't see any, if you got even numbers, there's no sense not dividing by 2. So 18 divided by 2 is 9, 30 divided by 2 is 15. Now you look at the 9 and the 15, and you say, well, 2 doesn't work, but how about 3? Yeah, 3. 3 goes into 9 3 times, 3 goes into 15 5 times. It's a 3/5. That would be our fraction. By the way, if you happen to have a nice calculator such as Casio FX 300 and ES is nice, then you could actually, on your calculator, you could do this, 180 divided by 300, and this is what it will display. It will display the fraction for you. I love that. Now you might be saying, well, what if I want the decimal? Well, then you would hit what's called the SD button on the calculator. If you have the calculator, you'll see it, SD button. And it would tell you immediately that it's 0.6, which I'll make it a 0.60. Of course, if you don't have that calculator, what you could always do, maybe in a different color, is you could always do 3 divided by 5. Remember this idea? Any fraction can be turned into a decimal by just doing a division. Top divided by bottom. 3 divided into 5 equal parts means there's 0.6 in each part. That's what that's telling you. 0.6 in each part. And then, lastly, to get a percent, remember decimal to percent, D to P. Put the D and P in alphabetical order there. So D to P, you would have to go to the right 2 places, always 2 places, never anything else but 2 places. 2 places, I'm talking 2. And so the 0.60 becomes a 60%. So yeah, that's what we were doing last time. Here's just another slightly different example. It says, okay, do color. It says 937 out of 1218. Hey, sounds like there's the same kind of problem, right? So hey, let's do it. 937 out of 1218. Woo! And it says just percentage. So what I'll do is on my calculator, I will actually do, I won't say equals, it is equals, but I will actually do 937 and divide it by 1218 to get a nice decimal out of it. So 937 divided by 1218, boom! Now I've got that calculator, so it shows me the fraction, 937 over 1218. But that's okay, I've got an SD button right here, boom! Point. It's 3 decimal places, we'll call it 0.769. 0.7692, so it rounds to 0.769, which again, you move the decimal 2 places, so that's a 76.9%. Okay, be careful. You want to read the actual question, right? Some people, sometimes it gets really easy to just kind of get in a groove with your homework and you say, well, these problems are all the same thing. I'm just going to put this over this. I'm going to put this over this. Here I go, put this over this. Yeah, I'm going to keep doing this. This is great. This is fun. That's what I did here. I put this over this. Blah, blah, blah. But did I actually answer the question? Careful, careful, careful. 937 out of 1218 said yes, which means this 76.9% is talking about how many people said yes. Is that the question? It says what percentage, go on you, what percentage was against? Oh, that's no's. We want the no's, not the yes. The no votes, not my nose on my face, but no votes. So what you can do is you can say, well, there's 100% altogether, right? And they either said yes or no, which means there's only 2 parts here. So you take the 100%, subtract the 76.9%, and what do you get? Like 23.1%, I want to say, were against or said no, or however you want to say it. Okay, so just be careful that you read the problem. Or that you read the problem carefully. Be careful that you read carefully. Yeah, something like that. By the way, is another way you could have done this, right? You could have done it this way, and there's no reason not to, really, so might as well show it up here. Actually, you know what? I am going to, let's see, does this work? I'm going to try to do, hey you, I'm going to try to do one of these deals. Oh, come on, you. Yeah, there it is. See? Get out of my way. I love that. Oh my God, that's so much better than real paper. So anyway, another way you could do this one, and let's maybe do it in purplish, is you could say, well, 937 yes means that everybody else, and there were 1218 altogether, so if you subtract the 937 yeses, what do you end up with? You end up with 281 no votes. And you always say out of the total, out of 1218 total, is, and if you do 281 divided by 1218, guess what? You're going to get 23.1%. Of course you will. Okay, so you can approach these problems different ways. The secret is to try not to let yourself fall into a routine where you're just saying, I'm going to take this number, put it over here. I'm going to take this number, put it over there. Very dangerous in a math course. Okay, so anyway, I made that point. Now, here's something a little bit new, and actually this is one of the niftiest things of means times. Maybe you've heard that before somewhere. It usually comes up in word problem kinds of context. Hey, of means times. This has never failed me. So what am I talking about? I'm talking about like Biff. I'm talking about Biff eating cookies. When it says he ate 2/3 of the cookies, it means he ate 2/3 times the cookies. It will tell you how many cookies he ate, 2/3 times the cookies. So part A, there were 24 cookies to begin with. Well, he ate 2/3 of them. And the 24 is the them. There were 24 cookies. He ate 2/3 of means times. Them is a 24. And I could put it over a 24 over 1 to make it look like a fraction. You can grab out your calculator and do this really quick. Like the way you do this is you see this fraction that's 2/3. The way you enter 2/3 is you go like this, 2, and you divide by 3. And you don't have to hit equals or anything. We can keep going here. And then this part that says times 24, we can just say time. Just keep typing these on your calculator. So you hit 2 divided by 3 times 24. And of course you could put divide by 1, but you don't really have to divide by 1. That's not going to change anything. So 2 divided by 3 times 24 gets you 16. Just type it in. It'll work. 16. That's a nice way to be able to work your calculator. If you can work your calculator like this, life is going to be so much easier. You just say, hey, 2/3 times 24. What do I do? What do I do? I do 2 divided by 3 times 24. Boom. Divide by 1 is optional again. If you wanted to do this the old-fashioned way, what am I doing here? Hey, why are those things still there? I want these out. Okay. So, we said 16, right? The old-fashioned way, the stuck in a math class with nothing but a pencil way, would be to, remember how to multiply fractions? You multiply straight across top and bottom, but first you would say, oh, I can cancel 3's here. So 3 goes into 3 here 1 time, 3 goes into 24 8 times. Now that I've reduced and cross-reduced, I can multiply straight across on the top. 2 times 8 is 16. Straight across on the bottom, 1 times 1 is 1. And of course, anything over 1 is itself. Anything divided by 1 is itself. It's 16. So you get 16 either way. So most likely we're going to be doing the calculator way for this course, right? But it's worth, remembering how this stuff goes. It's fun. It's fun. Now let's look at this one. See, this one's a little different. I know it's different because it says B, not A. Still says 24 cookies, so what the heck's different? Biff ate 24 cookies. Oh. Now, we're still saying he ate 2/3. We're still going with that. He ate 2/3 of the cookies. But the thing to note here is that the 24, that's not 24. That's not the 24. We didn't say that there were 24 cookies altogether. We said he ate that many. He ate 24. So what he ate was 24. So I'm going to maybe write it this way. I'm going to extend my little sentence here by saying 2/3 of the cookies is 24. And I'll look at this part of the sentence, okay? So when he ate 2/3 of the cookies, that came out to 24. See what I'm saying? Came out to 24. So how do you solve this then? Well, a little bit of algebra class, just a little bit of algebra class. 2/3 of means times how many cookies? I don't know. When you really don't know, that's what x is for. I don't know, x. So 2/3 of x, 2/3 times x is 24. And that becomes our little equation that we have to solve. Now the way you solve, pardon me, the way you solve this kind of a thing is if you want to get rid of the 2/3, you can multiply by the reciprocal. See how that works? It works because you could cancel the 2's, you could cancel the 3's. It's just a 1x. Cool, it's just an x. So what is x then? X is, you take that 24 and you want to multiply by the fraction. So you multiply by the 3, and because the 2 is on the bottom, you're dividing by 2. 24 times 3 divided by 2. And if you do that, you get 36. So actually, there were 36 to begin with, and if you check it out, 2/3 of 36 is 24, right? So yeah, there were 36 to begin with. And a quick PS, how would you do this back in math class without a calculator? You would do something like 24, you'd put it over 1, you'd say times 3/2. You'd do that whole cross cancel thing again. 2 cancels into 24 12 times. Across the top, 12 times 3 is 36. Across the bottom, 1 times 1 is 1. 36 divided by 1 is 36. Of course you get 36. Of course you get the same answer. You have to get the same answer. Okay, next. Now we have kind of the same thing. It's a percentage instead of a fraction. What color can I use today? How about that one? So it's still kind of a of the marbles. We're talking Bonnie painted 37% of the marbles. There's that of again. So 37% of those. So she painted, and you don't have to write this phrase down, but you certainly want to think this phrase. Painted 37% of all the marbles. And then you say, well, what's this 8240? It says there were 8240 to begin with, so she painted 37% of those. Of those. So she painted 37% of the 8240 marbles. And that's the question. How much is that? Now here, of means times. And remember this idea that when you have decimals and percents, you can turn the percent into a decimal by going this way, 2 jumps. So that's a 0.37. So whenever you've got a percent showing up in your equation, you don't want that there. So what you do is you change the percent into a decimal so that this is really just a pure number. Okay, percent is not really a pure number. It's a funny thing. It's 37, and the percent symbol says, by the way, you're dividing by 100 here. It's 37 parts out of 100, which, by the way, is 0.37. So anyway, 0.37 times the 8240, and we can just do this with our calculator. 0.37 times 8240, you get something like 3048.8. So probably you want to call it 3049. She probably painted, I'm assuming she painted whole marbles and didn't stop halfway through or whatever. So probably like 3049. Yeah, something like that. 37% of 8240 is 0.37 times 8240. And by the way, that's usually how people say this. You want to find 37% of something? Make that a 0.37 and multiply. That would be the short way of saying it. In fact, I'm going to say that. I'm going to say that. To find 37% of something, multiply it by 0.37. And we did. And we got 3049. Okay, cool. So that's nice. Very calculator friendly there, right? Okay, this next one, B. Bonnie painted 8240. How many were there to begin with? Well, there's something different here. Do you see that? She painted 37% of the marbles. Were these the collection of marbles that she started with? No, that's what she actually painted. So 37% of the marbles comes out to 8240 marbles. So now just focus on this part. 37% of the marbles that we started with got painted. How many got painted? 8240 got painted. So 37% of X really got painted and equals 8240. So you take that 37%, turn it into a 0.7 again. That's the numbers that we started with. So 37% of those marbles got painted and came out to a number of 8240. To solve this one, you would basically take the 8240 and you would divide it by 0.37. Maybe I'll show it this way. What you want to do is you want to get X by itself. That's usually how people say this. And if that says 0.37 times X, you want to do the opposite of times, which is divide. So you put the 0.37 underneath. Personally, I just look at that as I'm canceling the 0.37 off the X. In any case, 8240 divided by 0.37. This is how you would enter it on your calculator. This is how you enter all fractions. If you want to turn any fraction into a decimal, take what's on top, divide by the bottom. I'm going to do that here. 8240 divide by 0.37. Did I do this? I hope so. I got. You ready for this one? 22,270.27. Probably round that to 22,270. That's a lot of marbles to start with. I hope she's not the only one painting these things. But notice in all of these examples, of means times, of means times, of means times, the main thing you have to keep track of is whether the number they give you, are you taking 37% of this, or is that what you get when you take 37% of something else? Right? You have to keep that. You have to, and you just go by the wording, right? You say, well, she painted 37% of the marbles. Well, how many marbles were there to begin with? And that's not what this means, right? If that's not what this means, then we're going to have to put an X there. She painted 37% of whatever the heck we started with, and that came out to 8240. Okay, this is the way you have to learn to talk yourself through these things, and you start using the same phrases over and over, you start to believe them. Become very confident and sure and stuff like that. Okay, page 2. Page 2. These are going to be slightly more trickier because they're going to involve a little more thought. So we start in the usual way. We say of means times, right? That's what we say. That's what I say. So I'm going to write it this way. Generally speaking, this is always true. You can always start with this thought, if nothing else. We take a percentage of the whole enchilada to find the part. It's supposed to say find. To find, that looks terrible. To find the part. Maybe I could zoom out a little bit here. Okay. We take a percentage of the whole enchilada to find the part. Cool. So, what percentage have we got? We've got a 34%. Cool. Now, we're going to have to figure out what the whole enchilada is, and we're going to have to figure out what the part is. Okay, so going on the phrasing here, 34% of the kumquats, so the whole is all the kumquats we started with. I don't know if you want to write the whole phrase down, but all the kumquats we started with is, and it says here, those are the ones that went bad. So that would be the number of bad ones. Cool. Okay, we're getting somewhere. So you want to focus on the phrase right there. That phrase right there contains wisdom. 34% of all the kumquats went bad. That's exactly what I wrote here. 4% of all the kumquats went bad. Okay. Now, you read some more. And what I'm seeing here is there were 55 good ones left over. Okay, I got a 55. What can I do with the 55? Where to put the 55 is the question. Where to put the 55? Is 55 the number of bad ones? Nope. Is 55 the number that we started with? Nope. 55 is the number of good ones. Ah, darn. So what that means is that we're not going to be able to set this up as an equation because we don't know how many kumquats we started with. We don't know how many were bad. What we know is how many were good. Now, in these cases, I like to always draw some kind of a picture to kind of keep track of what the heck's going on here. So pictures usually go like this. You say, well, I had a whole bunch of kumquats, right? There's my kumquats. So I'll just say all the kumquats right there. Now, some of them are good and some of them are bad. 34% were bad, so I'm going to kind of try to make it look something like 34% and put a line there, right? So these are the bad ones, these are the good ones. And this was 34% of the total. And this was, well, it was, they didn't give us the percentage, they gave us a number, 55. I'll put the number in here because I like to put the actual number in here. 55 good ones, how many bad ones? I don't know. We'd like to know. How am I going to get anywhere with this? Well, what we can do is we can do this little trick right here. See this 34%? Well, what's that then? What percentage is that? You can figure it out because there's only good and bad, and it adds up to 100% no matter what. So if it adds up to 100% no matter what, this must be, would that be 66%, right? Yeah. This must be 66%. And now I can make a little phrase here. 66% of all the kumquats. I don't even know what a kumquat looks like. Anyway, 66% of all the kumquats were good. And we have the numbers. 66%, I'm going to call that a 0.66. Of means times all the kumquats. Well, I don't know what that is yet. But I know that that comes out to 55. See, if I only have one thing I don't know, I can solve. So this is great. So I'm going to say x is 55 over 0.66. And when you do that on your calcu type later, you get, what I get? I got 83 1/3. So maybe 83 altogether. Now, again, keep track of yourself. What did you just solve for? I just solved for, what? This. That's all the kumquats. We had 83 kumquats. So come back up here. Come back up here. We're over here now. We had 83 altogether. So if that's 55, 83 minus 55 is, what the heck is that, 28? Did I do that right? 55, 75. Yep, 83. And that's the number. How many went bad? The answer is 28. ANS. By the way, if you do a lot of scribble work like I do on my homework, somewhere along the line you want to tell me what's the answer, right? Just circle it, maybe put an ANS or something right next to it. Just be very clear. If I can't tell what the answer is, how the heck do you get points, right? So anyway, we had to think that one through, didn't we? This would be a good problem to revisit at some later time. Just cover up the work you've done here. Look at the problem again and say, now, how did we go through this? And you might remember part of it and say, well, we drew a box, right? We had bads and goods. And see if you can step yourself through it just by kind of asking yourself little questions. So what is this? What is that? How could I, what equation could I use? Where could I, blah, 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 blah. And if you get stuck, of course, you uncover it and say, oh, yeah, that way. And that, by the way, is quality brain cell construction, because whenever you try to figure it out, and you're so close, and then boom, you get it or you see it, it sticks better. Here's another one. I like this one a lot. So Claire walks into a diner. She's got $30 in cash. She's got nothing else. No credit card, nothing. Just $30 in cash. Now, she wants to be sure to leave at least a 20% tip. And the question is, well, how much can she spend before the tip? Okay, now you want to piece this together carefully. Okay, let's start with my my basic phrase. What did I say up here? I said we take a percentage of the whole to find the part. So let's do that. I'm going to write that here. We take a percentage of the whole enchilada, whatever that is, to find the part. Okay, so the percentage that we're talking about is right there, 20%. So we're going to take 20% of something. So don't read the question. Well, you have to read the question, I guess. But ask yourself, what are we tipping? When we tip 20%, we're tipping 20% of what? Well, we wait for someone to hand us a little slip of paper that says that meal cost you this much, and then you pay 20% of that number. You pay 20% of the bill, right? 20% of the bill. And that gives you what? Well, that would give you the tip, right? So 20% of the bill is the tip. Cool. So let's grab that $30 number now. Where does $30 go? Well, that's not the bill. That's how much she's going to pay altogether. It's not the tip. It's how much she's going to pay altogether, right? It's how much she's got to pay. It's not the bill. It's not the tip. That equation, by itself anyway, is not going to do us any good. So maybe I don't have to draw a picture this time, but I probably do have to change colors. So I'll change colors. So I'll say, consider what is going on here. We're being passed a bill, and then we're going to add a tip to it, and that's going to be the $30, right? The bill plus the tip are going to add together to $30. Now the bill is, we have no idea. I'm going to use an X now. I have no idea. In fact, maybe I'll use the X a little closer to the equation. What do you say? What do you say? But the tip, well, actually, we got a little equation for the tip right here, so to speak. It says the tip is 20% of the bill. 20% of means 20% times. Times what? Times the bill. What's the bill? I used X for the bill. Huh? What do you think? That came together kind of sweet. So the bill is, I don't know, X. The tip is 20% of that number, which means 20% of that X. And those together add up to $30. Cool. There's our equation. It's only got an X in it, so we should be able to solve here. Now, the key to being able to solve this thing is to recognize that what I've got here is called like terms. And remember, like terms can be added and subtracted together. We have a 1x and we have a 0.2x. So if you add the 1x and the 0.2x, you get 1 plus 0.2 is 1.2. So you get 1.2 times x is $30. So I hope you've seen this like term stuff before. 1x plus 0.2x, you just add the coefficients together. We call these the coefficients. The 1 and the 2 are the 0.2 are the coefficients. Anyway, 1.2x equals 30. Now to solve this, we're going to want to cancel that 1.2 on both sides. And so x is 30 divided by 1.2. And what did I get? I got actually a perfect $25. Which means we might have been able to just guess our answer to this one. But consider $25. If that's the bill that they hand you, hey, you owe us $25. Well, 20% is another way of saying 1/5, because 20 over 100% means over 100. 20 over 100 is 1/5. And 1/5 of 25 means take the 25 divided by 5. You get $5 for a tip. 25 plus 5 is 30. Yay, it worked. But often you're not going to be able to guess. And so you're going to have to piece it together like this. So always, any percent problem, you want to start with this idea. A percentage of the whole enchilada gives you the part. And you can start to write that out because they'll give you a percent, or maybe you have to solve for the percent, but they'll usually give you a percentage, and then you have to say, okay, I want to take the percentage of what now, and that's going to give me what now, and then see if they give you one of these. On page 1, they always gave you one of these, and you were able to put the number in and solve. On this page, they didn't. And so you had to come up with some other thing, some other angle on the problem. So, think of another equation. Here it was, well, the bill and the tip are going to add to 30. What was it on this one? It was like, well, the good ones and the bad ones add up to 100%. Something like that. Okay, one more on this page. Darla's Dental Rinse. This is a product you can get at some store somewhere, right? Darla's Dental Rinse has a nice claim on the bottle with the big shiny star and all that stuff, and maybe a couple exclamation points and somebody smiling, and picture of a smiling family with really white teeth, and it says, hey, this removes 200% of your plaque on your teeth. Woohoo! Remove 200% of the plaque. So I just want you to picture yourself in the store looking at this bottle that says it removes 200% of the plaque and asking yourself, are you impressed? That's the only, and if so, why? And if not, why not? I guess is the full question. So how impressive do you find that? Well, I'll tell you one thing. I'm not impressed. We are not amused. No, I am not impressed. Why am I not impressed? Because this tells me they don't understand what their numbers mean. They don't understand their numbers. They've got some data on a clipboard somewhere, but they don't really know what it's telling them. They don't understand their numbers or their data or whatever. Why don't they? What's wrong with 200%? I'll tell you what's wrong with 100%. If you remove all the plaque, if you remove all of it, that would be 100%, right? The plaque is the hole that you're trying to remove. You remove all of it, that's 100%. How can you move more? You've already taken it all off. It's gone. It's gone now. Can't remove any more. You can't remove 101%. You can't remove 102%. You certainly can't remove 200%. It's a nice looking number, especially if you put a shiny star and stuff. But be careful for this kind of stuff, okay? So big part of statistics is you want to just kind of keep your eye out for things that aren't quite right. And you just have to develop a habit of saying, well, what does this mean? What would that mean? Would that mean... And don't just accept a number as, hey, that's a good number. I like it. Okay, so hopefully you didn't fall for that one. But if you did, don't fall for it again. Okay. Now, on the last page, I want to talk about something called percentiles and quartiles. You've all heard of percentiles before. What does it mean if you get a score that's in like the 80th percentile or maybe the 70th percentile? A score in the 70th percentile, let's put it this way. You get a score on a test or whatever. A score that's said to be in the 70th percentile is supposed to mean that that score is higher than 70% of all the scores. So you have to imagine that somebody listed out every single possible score on this, whatever it is. They listed out all the scores in order, and then they said, well, let's walk 70% of the way across here toward, from the small towards the bigs, and then you'll get to a number, and you'll say, well, that number represents the 70th percentile because 70% of all the numbers are smaller. That's what it means. So I got two kinds of examples here. The first is just, I thought I'd do letters of the alphabet. Now, in order, again, you don't want to list them in order because the alphabet is usually, we can think of that as an A, B, C, D, X, Y, Z. That's how we think of the alphabet, right? It's in order. So, which of those letters is in the 70th percentile? What you have to do is you have to say, well, there's 26 letters. Now, if you kept walking 70% of the way across these 26 letters, right, you'd want to figure out where am I. So you'd say, well, what is 70% of 26? It would be take the 70%, make it a 0.7, multiplied by 26. What am I getting? I'm getting an 18.2. So call it the 18th letter. The 18th position, really, but the 18th letter in the alphabet would be, and you just have to go A, B, C, D, R. So the R would be in about the 70th position. It's kind of like saying when you get to R, you're about 70% of the way through the alphabet. Kind of the same thing, right? So that's what percentiles are. I do want to stress, in order is necessary. If I ever give you a homework problem or a test problem where everything's all mixed up, the first thing you have to do is put it in order. Then you can start talking about percentiles. Now we can come at this from the opposite point of view. So this was saying, I have the 70th percentile. What letter is that? This is saying, I got the letter. What percentile is that? So the letter E is what percentile? Well, first you have to say, what position is it in? Percentile is about position. So it's in the 5th position, A, B, C, D, E. Out of, there's 26 total positions, right? So fraction-wise speaking, we're talking it's in the 5th position out of 26. So you do 5 divided by 26 to get a decimal. It comes out to 0.192. You do this, and it comes out to the 19.2th percentile, but we always do whole numbers for percentiles. 19th percentile, just about. So let's make a point of that, right? Always a whole number. I've never seen anybody ever say, you're in the 19.2th percentile. I've never seen that. Always a whole number for their percentile number. Okay, 19th percentile. That's where you are. Okay, cool. Now, didn't leave myself enough space here. Oh well, we'll just have to improvise. I suppose I could use space down here, right? Yep. I think on your sheet I made more space here, so it's not going to be as much of a problem. But anyway, now we've got Frisbee golf scores. 12, 12, 12, 14, 18, 18, 19, 20. Those are the scores at the Frisbee golf tournament. Apparently we had 8 participants because there's 8 scores here. Cool. Now notice they are in order. Again, you have to first make sure your numbers are in order, smallest to biggest. You wouldn't want to have the 12 and then the 20 and then a 12 and then the 18 and then a 14 and then a 19. You wouldn't want to do it that way because that would not even make sense. So put the numbers in order. Okay, now we can do stuff like this. The 14, where's that? It's right there. It's in the 4th position. Percentiles are about the position. It's in the 4th position. Out of, and then how many positions have we got here? We've got 8. We've got 8 positions. So we're in the 4th position out of 8, which is a half, which is 0.5, which is the 50th percentile. 50th percentile. Note, the 50th percentile is also called the median. Perhaps you've heard that word before. Median means the score in the middle. Like a median strip on a highway. It's in the middle. So when we say 50th percentile, we could also say that the 14 is the median. 14 is median. Now here's a problem. And this is why I need more space. Maybe in a past class somewhere you found medians before. Do you remember how you find a median? You say, again, you use this definition. It's in the middle. Well, the middle of 8. Come on, you. What are you doing? Okay. This is where the median would be, right? It splits the scores in half. I got 4 on the left. I got 4 on the right. It's split. That's where you would put the fence, so to speak. Now, what number is on this line? There is no number on that line. So what we do in that case is to say, well, I'll split the difference between the 14 and the 18, which is a 16. And really 16 is the true median for this data set. But wait, we said the 50th percentile was 14. We said the 14 was the median, right? 16 is the real median. What's going on? Well, I have to bring up an issue here. So I'm going to do that down here on the blank page. This is what we mean by percentiles. The percentile idea is to break the data into 100 equal parts. So what would that look like? Well, I have a big list of numbers here. Just pretend that's a big list of numbers. And then you want to break it into 100 parts. So you go, like, there's going to be a lot of parts here. Try to picture there's 100 parts there. Okay. Now here's where 0 would be. The 0% would be. There's where 100% would be. We never say 100th percentile. We never say that a score is in the 100th percentile. Why not? Well, to be in the 100th percentile, your score would have to be higher than 100% of the scores. Well, it's not higher than your own score, so it's not really going to be higher than 100% of your scores, right? So we have to call this one the 99th percentile. The one on the end there is the 99th percentile. Well, the problem with doing that is if you call that the 99th percentile, notice that would be a 99 right here. It would be to the right of the 99. Well, then the first percentile would be to the right of the 1. And so what do you call this? There's no name for it. Because also, we never say 0th percentile. We just don't. I suppose it's possible in my mind to say, hey, this score is higher than 0% of the data. Seems to me like that would be possible. But we never say 0th percentile either. So all of a sudden it's like, well, how are you supposed to do this then? You can only name 99 of these. You break it into 100 equal parts, only 99 have names. There's a problem here. And the real problem, the really big problem is there is no agreement about the best way to define percentiles. And it's because of this problem. You've got 99 names for 100 equal parts. What the heck, right? There is no agreement about the best way to define your percentiles. So, my conclusion is there's no best way. I'm just going to let myself play fast and loose. I'm not going to worry about this problem. I'm not going to worry about it. I'm just going to say, you know what? Heck with it. 14 is the median. Yay, 14 is the median. Why? Because it's the 50th percentile, and I want the 50th percentile to be the median. So, again, we're just going to play fast and loose. So don't worry about it too much. This problem kind of goes away when you have a big list of numbers, because then you're much less likely to be off by any real amount. So it kind of goes away with large data sets. Usually in statistics, we're playing with large data sets. So if it's a problem that goes away with big data sets that we usually use, and if it's a problem that nobody has been able to find a way that everyone can agree with, well, okay, fine, we'll just do part over whole like we usually do. It's in what percentile? Well, it's in the 4th position out of 8. Just do it that way. It's in the 4th position out of 8. Moving on. What score represents the 3rd quartile, which means 75th percentile? First, let's just do this, and then I'll talk about what the heck's a quartile. So the percentile, 75th percentile, would mean we want to find 75% of our way across. How many positions have we got? 1, 2, 3, of 8 positions. There are 8 positions total. If you walk across 75% of them, you would want to find 0.75 of means times 8. You would get 6. So the 6th position would correspond to the 75th percentile. And so you just walk across to the 6th position. 1, 2, 3, 4, 5, 6. And you say, yeah, it's an 18. 18 is the 75th percentile. And that's the end of the lecture, really, except that I need to talk about, well, what's a quartile? Okay, that's not a really big deal. What's a quartile? It goes like this. Quartile is based on the word quarter. So just try to imagine that that's the big list of numbers for our data, right? Well, cut it into 4 equal parts, not 100 equal parts. 4 equal parts, and those are called quartiles. Now, this number here is usually called Q1, which means the border for the end of the first quartile. This number here can be called Q2, but it's usually called median because it's right in the middle. And then this number that we happen to hit right there would be called the Q3. Now, quartiles don't cause as much fuss as the percentiles because we basically said if you're in here, you're in the first quartile. If you're in here, you're in the second quartile. If you're in here, you're in the third quartile. And how do we get around this position? We say, we don't want to say fourth quartile. We say in the top quartile. Got around it. We got around it. In the top quartile. Not usually I guess I might hear somebody say the fourth quartile, but top quartile is usually what you hear. So you could be in the first, second, third, or fourth. You might say the bottom quartile, but top quartile is how you would refer to that one. So basically, quartiles are, you can get those by just thinking of this as the 25th percentile, thinking of this as the 50th percentile, thinking of this as the 75th percentile. If you just think of a quarter as 25%, then the first quartile is the 25th percentile, which again, percentiles, quartiles, they're referring to a position. What number is 25% of the way across the list? So 25% of the way across this list, just for one more little thing to do here. Quarter one, I would find 25% of 8 positions. That would be 0.25 times 8. That would be 2. I look at the second position and I say the first quartile is 12. Roughly. It's close. Actually, it is 12. I think even if we were really careful and said that's the first quartile, because it splits into 2 groups here. Well, between 12 and 12 is 12. So yeah, I don't. We could play fast and loose with our percentages like this. That's fine. But just kind of remember this idea that the quartile, like a percentile, it's talking about the position. It's not talking about like how big the number is itself. Wow, I went 46 minutes on this one. I better finish. See you in the homework.